Hello everyone, I am Anitha Krupanidhi, working as an assistant professor of chemistry at Marri Laxman Reddy Institute of Technology and Management. Today I am going to discuss about the topic engineering materials. So this is the syllabus of engineering materials. So before going to the topic, first we'll see what is meant by engineering materials. Okay, so what is meant by engineering materials means, so here it is engineering materials, the substances or the materials which are used in different fields of engineering. Okay, so there are different fields of engineering are there, like civil engineering, mechanical engineering, electrical engineering, and chemical engineering, etc. Right, so in these different fields of engineering, whatever the materials we are using, that is called as engineering materials. Okay, so if you see the definition or the introduction, the substances or the materials which are used in the field of engineering are called as engineering materials. For example, if you take civil engineering, we are for construction purpose we are using iron concrete, cement, etc. And next, if we take electrical engineering, in the electrical engineering we use the copper and then tungsten filament. To cover the tungsten filament we are using the glass, right? These are the materials we are using in the electrical engineering. And next, if you observe in the chemical engineering, uh, we are using the chemicals, we are using chemicals, and all those chemicals we store in the containers, and those containers once again made up of metals, right? So like this, there are different kinds of materials we are using in the field of engineering. Those are called as engineering materials. Clear? And next, these engineering materials are broadly classified into two types, that is metals and the non-metals. And these metals are of two types. Metals are classified into once again two types, ferrous and non-ferrous materials. And these ferrous means in which iron is the main constituent, and next non-ferrous means iron is not the main constituent. If you see the non-metals, these are once again classified into organic materials and ceramic materials. And next, organic materials examples are polymers, plastics, rubbers, thermoplastic and thermosetting polymers, in which carbon is the main constituent. Those are called as organic materials. And next, in the ceramic materials, these are the examples like refractories, abrasives, glass and cement. Okay, these are comes under the non-metals. Now here our today's topic is cement. We will discuss about cement. What is meant by cement, and what are the properties of cement, and next step, how the setting and hardening of the cement takes place. So first we'll see what is meant by cement. So what is meant by cement? Cement is a construction material with adhesive and cohesive properties. Okay, these two are the main properties of the cement. These two are the main properties of the cement. What is meant by adhesive? Adhesive means it has the ability to stick to the surface, right? So if cement, just suppose here one brick is there, on the top of the brick we have applied the cement. If only it sticks to the brick, it is not enough, right? It is not enough. If one more brick is there, or the building block or the stone is there on the top of the cement, it has to bind these two bricks. Okay, it has to bind these two bricks. That property also a cement should have. So it is called as a cohesive property. Clear? So here cement is a construction material with adhesive and cohesive properties. Okay, these two are the main properties a cement should have. It is used to bind building blocks, bricks or stones, etc. Now, what are the main constituents or the composition of the cement? So the essential constituents for the construction of the cement are calcium and aluminium and silicon. The term is given which is called as it is a calcareous and argillaceous. These are the essential constituents of the cement. Now these cements are classified into these cements are classified into two, these are the following types. Cements are classified into natural cement, slag cement, Barcelona cement and Portland cement. Now this Portland cement, in your syllabus we have the Portland cement. Now we will discuss about Portland cement. What is meant by Portland cement? What is the composition of Portland cement? How setting and hardening of the cement takes place? All these topics we will discuss now. What is meant by a Portland cement? Okay, so it is a Portland cement, and this Portland cement, how it is the name is given for this Portland cement. Mainly this Portland cement was patented by Joseph Aspdin in 1824. The name Portland cement was used because when it is mixed with water, it sets to give a hard stone-like mass, and that stone-like mass, it resembles a Portland rock which is in England. Okay, so this Portland, this is a Portland rock in England. So here, after setting of this, when we mix water to the cement, setting takes place and then hardening takes place. So here, in this setting, after setting, this rock resembles this hard mass resembles the Portland rock in England. Okay, so that's why it is named as Portland cement. And this Portland cement, it is a type of cement, not a brand name. Every cement manufacturer makes a Portland cement. This Portland cement, it is widely used non-metallic material used in construction. And this Portland cement is hydraulic in nature. Okay, it is hydraulic in nature. Hydraulic in nature means what? It is a property of both setting and hardening in the presence of water. So that's why it is called as a hydraulic in nature. A cement should have this property also, that is the hydraulic in nature. Now we'll see what is the main composition of the Portland cement. This Portland cement consists of, this is the main composition, these are the main constituents. These are the main constituents, that is lime, it is the major constituent 60 to 70%, and then silica, and then alumina, magnesia, ferric oxide, sulfur trioxide, sodium and potassium oxide. These are the main constituents present in the cement. And when we mix water to the cement, this total composition, okay, so whatever the composition, all these constituents are there, how all these constituents reacts with water, that we will discuss we will discuss now. So here in this Portland cement, in this composition, mainly if we have to add this in the prescribed percentages, but here excess lime is there in the cement, it will give cracks during setting. If excess silica is there, it produces slow hardening. Excess alumina is there, it weakens the cement. Okay, and the presence of iron, it gives color. Cement generally it is in which color? It is in dirty grayish in color, right? So how that color comes to the cement means due to the presence of iron. So because of the presence of iron gives color and also strength. Okay, it gives color and also strength to the cement. And next we'll see what is meant by setting and hardening of the Portland cement. How this setting and hardening of the Portland cement takes place. Okay, so just now we have discussed that when cement when water is mixed to the cement, then it produces what? It produces a plastic mass. Okay, as such cement, if it is in the form of a powder, there is no chemical reaction. Okay, so if it is in the form of a powder, there is no chemical reaction. When you add water, when you mix water to the cement, then only the chemical reactions starts taking place. Okay, so here just we have written a word cement here, but here cement in the sense it contains the total composition. Okay, so that total composition like CaO, Al2O3, SiO2, Fe2O3, all this composition is there. How this total composition is reacting with water? Okay, how this total composition is reacting with water, one by one we will discuss the chemical reactions now in the setting process. So here what is the meaning of setting and hardening means? When water is added to the cement, first it gives a plastic mass. So here plastic mass means it has the property of plasticity. Okay, so it has the property of plasticity. It has the property of plasticity, and it loses its plasticity. If it loses its plasticity, then what happens? It becomes a hard, right? It becomes a stiff and then hard. It becomes a stiff. It becomes a stiff and then hard. So it becomes stiff and then hard. Ultimately, a rocky mass is obtained. Okay, so a rocky mass is obtained, which is called as this total process is called as setting. Okay, so this total process is called as a setting of the cement. So when water is mixed to the cement, it produces a plastic mass. Plastic mass means it has the property of plasticity. Then afterwards it loses its plasticity, and then it becomes a stiff, and then finally a hard mass is obtained, which is called as a setting process. Okay, this total process is called as a setting. Now, how the hardening of the cement takes place means after setting of the cement, it leads to the formation of gels and crystals. The formation of these gels and crystals, the cement gets hardened. Okay, so this development of it will give a strength to the cement due to crystallization. Now we will see what are the chemical reactions takes place when you add water to the cement. Okay, so here in the initial setting, when cement is mixed with water, what happens? It becomes a paste which has the plasticity. Then it becomes quite rigid within a short time, which is called as a initial setting. Okay, so here this is due to the what is the chemical reaction takes place in this initial setting. In this initial setting, here it is 3 CaO, Al2O3 plus 6H2O. In this one, here it combines with water. It combines with water, and the heat is released in this step. Okay, so in the initial setting, what happens? The composition present in the cement. Okay, so what is the main composition is there? Calcium oxide. Okay, so here it is mainly first CaO, Al2O3. It reacts with water. And combines with water. And here heat energy is released in the first step. And next, when you add water to the cement, immediately, if the setting takes place, then it will not be durable. Okay, the setting process should be very slow. Okay, so what we have to do for this to slow down this process means, for this purpose we have to add the gypsum. Okay, this is the main step. To avoid, see here, to avoid early setting of this C3A, that is CaOAl2O3. So this CaOAl2O3, it can be written as C3A. CaOAl2O3, it can be written as C3A. So to avoid early setting of this C3A, what we have to do is we have to add the gypsum, which act as a retarding agent. So here gypsum is added. Why we are adding gypsum? What is the main function of gypsum means? Here it slow down the process of this setting. Okay, how it slow down the process of setting means it leads to the formation of an insoluble crystal. Okay, so insoluble crystal, that is C3A, CaSO4 and 2H2O. Clear? And the next one is here, if you see the next one, C4AF, that is CaO, Al2O3, Fe2O3. Now here Fe2O3 also comes into the picture. So that means it combines with the water. So cement means in that cement, what is the composition is there? CaO, Al2O3, and then Fe2O3, then SiO2, all these are there. So all these, the constituents present in the cement, one by one, it will, how it reacts with water. Now, I am explaining now. So here in the next one, the tetracalcium aluminoferrite, it can be written as C4AF. It reacts with water and forming both the gel and crystalline compounds. Okay, so it reacts with water and forms both gel and crystalline compounds. These two gels and crystals are formed in this step. Okay, so this total is the setting process of this Portland cement. So what is the setting of the Portland cement? First here C3A reacts, and then we will add water to the cement. In the cement, what in the composition, first the CaOAl2O3 reacts, and then to slow down that setting process, what we are doing, gypsum is added. Then afterwards C4AF is will react with the water. Okay, and here also heat energy is released. Now here in this setting of the cement, hydration and hydrolysis of complex compounds causes cement to develop a compressive strength. Here, because of the formation of the gels and crystals, it will give a strength to the cement. Okay, now we'll see what is the final setting of the cement. In this final setting of the cement, what happens is, this is due to the formation of tobermonite gel and crystallization of calcium hydroxide. Next, in the final step, in the final setting, in that composition of the cement, this SiO2 combines with the water. So here tricalcium silicate, it combines with the water and forms both gels and crystals. Here this is called as a tobermonite gel, and here calcium hydroxide, it crystallizes out. So this is due to the formation of tobermonite gel and crystallization of calcium hydroxide. This tobermonite gel, it possesses very high surface area and high adhesive property. So already just now we have discussed that a cement should have adhesive and cohesive property. Okay, so because of the formation of this tobermonite gel and crystals, then it will give a high surface area and very high adhesive property. Now, in your syllabus, you have a few special cements. There are a few different types of special cements, that is white cement, waterproof cement, and high alumina cement. So, what is meant by this white cement is, it is a type of Portland cement. Portland cement is in which color? Because of the presence of iron, this iron imparts gray color to the Portland cement, right? So, here in this white cement, this is in a very low percentage of iron and manganese oxides are there, which this iron is responsible for the color, but here very low percentages of iron is there. That's why it is called as a white cement. And next, waterproof cement, it reduces its permeability to water. It used to prevent water seeping into the concrete. Mainly it is used in the leakages. It is called as a waterproof cement. And next one is the high alumina cement. In this high alumina cement, it is a rapid hardening cement. It is made from bauxite. And limestone. So bauxite means it is the ore of aluminium, and the highest percentage of alumina is there. That's why it is called as a high alumina cement. It is comparatively resistant to chemical attack. Now we'll see the conclusion. In this class, we have discussed about the types of cements. What are the different types of cements are there, like natural cement, slag cement, Pozzolana cement, and then Portland cement. These are the different types of cements we have discussed. And next we have discussed the properties of cement. So here, what are the properties of cement we have discussed, students? Where that is the adhesive property, and adhesive and cohesive property, right? These two are the main properties a cement should have. This one we have discussed. And then composition of Portland cement, this composition also we have discussed. Cement means just we are seeing a word, but cement means here what is the composition, what are the different constituents are present in the cement, that we have discussed. And then finally, we have discussed the setting and hardening of the Portland cement. How, when you add water to the cement, how the setting and hardening of the Portland cement takes place. That topic we have discussed, including equations. And next here in the setting and hardening of the cement, here in this from this composition, what are the different constituents react with water in a order we have discussed. And next one, the last one, we have discussed about the special cements. What are the different special cements are there that we have discussed. I hope this class is helpful to you. Thank you.